Okay. Hello, everyone, and nice to meet you. I'm Paolo from Proof, and I was requested to show you some example of using the Python library that we are developing at Proof for interacting with the R node, and I'm very excited to be here and show something. Share my script and stop my video because probably the internet connection is not so fast today. Let's see. Can you confirm that you see my screen?
Yes.
Okay, nice. So what I did already linked in Discord how to actually use the notebook here. There is a link to this repository here, rchain notebook. And anyone interested in testing this, either now or later, they can just follow the same instruction. It's just Docker Compose up, basically. It runs two containers. One is the notebook running Python 3.7 with the library already started, and the other one is, of course, an rchain R node, version 0.7. So let me go here and pass.
Paul, you're running a standalone node?
Yep.
Can you show us the command line, how you're invoking the standalone node? Because I think it's one area I'm tripping up on.
Yeah, this is also farther than I got when I tried this. I struggled to get the Python module installed.
So this is how I'm running the R node. And there is a Docker image in here. And you can see how I install requirements. And I'll explain today that to reach a configuration that is working for the R node 0.7, I had to actually make a workaround to the product buff, and I'll explain why. But basically, I also show the command like pip install is usually enough to have this working. Anyway, let me start from here. There is this notebook, and here there is how I'm intending to show you the things. I will have a very small introduction about how to do this stuff and what's the current status, and then use some code to do the basic stuff with R node.
So if any of us want to follow along with this, is that realistic, or is it too much setup and time to make that happen?
Right now, real time, you mean?
Yeah.
Maybe just downloading the image could take a little while, okay, like 2 minutes. But
what's the image and where might one find it?
Well, it's if you see the Docker Compose from this repo here, it's this one.
Okay, and where's this file?
It's still in this repo, same one. If you see here. Okay.
Okay.
There is a builds notebooker, and this one is automatically pushed to that image there. So you all right, so here it is. This is also a link to this live version read-only and some other links. Introduction, so you can either just follow in read-only mode as I explained, or interact locally if you do these three things. Clone this repo, go into the directory, Docker Compose up. That's what I'm just doing right now, same thing. And to find out the password, you have to look for this variable in .env or change it before running. Read-only mode is just using the MVU from Jupyter for this notebook. Okay. Proof platform. Why are we here and we are trying to use rchain? This is a platform that wants to enable this wisdom of crowds to vote for articles to be true or false. So people will come to register and vote in our platform on articles that are existing on the internet, and they will bet some tokens to, let's say, rank their conviction. And vote will close only when it reaches some parameters, because those are being studied in economics and other papers to let the crowd be wise. So when we tally the vote, we will find out what the majority says, and if it's a high enough majority, we would say that they decided something is mostly true or false, and we will agree with that. What's interesting is that we plan to use the blockchain to lock the tokens, of course, and then provide some cryptographic proofs that the votes that were executed during the vote system that was open, they weren't changed in any way. We have been testing in the past how to do the same with Ethereum, and it was really, really a lot complicated. And with rchain, it seems that we are having like different patterns that we can use better. So what we will try to show, I will not, try to show anything about how we do that proof. We already did a demo in the Hangout community, and there is a recording for that if you want to look into it. I can also paste the link, by the way. So what happened is that after we found out that we needed to interact with rchain, knowing that our backend is based on Python 3 and Django, we started to look into how to use Python to interact, and we found out that there was an official Python snippet. I have no idea who wrote this, but it's a nice one, and it's basically showing how to produce the client Python files for gRPC, and also how to show blocks, only that operation. So we basically forked and used our developer leader, Mateusz, who's known as Readonly, and he developed the main part like more than a month ago. And I updated recently to 0.7. Also, I'm using notebooks just because in the past I've always been a Pythonista and teaching coding with Python to data scientists. So that's why I'm really stuck to this, but I really love that. So what's the status? So let's run this code. We are currently reached the 0.0.10, and up to that version, this node is just working with the 0.6 R node. The upcoming release will be either compatible with 0.7, and the code that I will show today, it's actually this one, this release. I will not recommend to use this one for now, just because we have to find out about this issue, because the PR is blocked by a buff issue that I've encountered recently last week. Also, we didn't understand really why, but eval and repl commands are not really working for current Python gRPC missing definition. So we have to open an issue for that too. We didn't have much time, but we'll do that.
So isn't that intentional? The eval and repl
not working?
That it's not going to be on the clients, the external gRPC.
But don't they use the same one for the R node that then use the eval?
They may. There's also an internal gRPC port.
Oh, okay.
I have questions about whether that's exposed or not.
Oh, okay. Well, I don't know. I'll ask and I found out. So it's interesting to know. Thank you. So the short-term goal is that when we complete these parts that I just told about, we will try to move this repo that we have into the rchain GitHub space. We have an issue where we will ask people to create the repo and see what's the procedure there. Okay, so let's try to use some code. First thing, of course, it's about connecting. So if you are running this notebook, as I said, there will be an R node standalone instance. If we go to see here, here it is. And to access that, from here, we have a variable. And so, for example, if I just quickly install here, this image is based on Alpine. I don't know if people knows this one from Docker. So if I run this, I can check that, yes, it's reachable from my container, the same version. Okay, so at this point, all we can do is just open a channel to the gRPC. So if you don't have this installed, this is how you install it. And after installing, that's all you have to do. Just import from a module called Casper, create connection, pass the host name, and eventually another part if it's not the default one, and then we have a Python available connection. Okay, we can write some Roland code. Of course, the example that I show here would be very, very simple. Just for the record, in the notebook, you can write files just like this. So this content of this cell would be that file. And then after that, I can click here and go to the editor and use like the Vim inside and interesting stuff. I can say that syntax is Scala, which is more similar to Roland so far. And so, you know, everything works and it's usable just like you would with the normal editor. That's a funny thing about Notebook that I always show to students. Okay, so then after that, we will read the file, or either we write directly in Python something with the triple quote. This is a particular string that allow you to go lines under and use also other symbols that are not allowed usually, like quotes. So if I do this, I can now print my contract and use it. Next step would be deploy and propose. So if I do this and I go check the hard node, I can see that I received a deploy here. And if I propose, sorry, I have a new block here, which was added. Okay.
So does the Python library generate a timestamp for you and set a flow price and all that stuff?
Yeah, exactly. Yeah. So if I go here in Casper and see propose, yeah, this is the things that we create currently. We also have default value for flow limit and flow price based on the sessions that we had. Mm-hmm. So yeah, it's pretty simple up now.
How do those type annotations work?
You never use them?
Correct.
Okay, so this one is very nice just because you can specify using the Python language now the type that you're expecting here, but this doesn't mean that this is needed to be a string actually, but it's just more like a sugar syntax that will help people that read to find out what's this. And also the fact that if you run an helper that's called myby, they can check if you're using the right types when you're calling the function. So, you know, it's actually useful for unit tests and stuff like that. Also, it's very interesting the fact that you are storing this as a meta attribute, I guess. And so if you are querying in introspection in Python, this function or other things that are using the type ints, you can find that directly in the code, what you're expecting here, the class. So it's very nice. I would recommend to learn to use that. Okay, yeah, we checked and the hello world is here. So this means that our little contract was correctly deployed. Of course, if I was about to, let me see, how can I go back here? If I was writing some wrong contract here, the Roland code here would just trigger an error instead of the success tool. And we will actually see directly the same error that we would see with our node deploy of the contract. Okay, next step, let's play with blocks. So one thing that I could do is to get blocks. This is the equivalent, of course, of show blocks, and I can get similar stuff. So if I can get the hash here from the output, what I can do is that now I can get the singular block like that.
Could you go back 2 slides? This get one forward, I think, from here. Oh, so, yeah. There was a method that was essentially propose and listen. Maybe it was before this. It went by quickly.
No, that I showed that later. So it's actually after. It's in the, like, probably the one step after playing with blocks.
Oh, okay.
Okay.
Yeah, this one. Let's see, not this one. Keep going. Keep going.
This is where I arrived.
Oh, this one right here. Oh, okay. All right, never mind. I'll pick it up.
Yeah, sorry. So this is just get block, like meaning only one block. So it's expecting a block hash, the one that we just grabbed it with Python before. Now what happens is that I get the tuple space dump, which is nice. So I can see the whole thing here. It's very good. And also I can, you know, play with stuff like, well, what's the current block number and stuff like that. Another thing that I forgot to mention is that, as you can see, everything here using this library is currently converted into a Python dictionary. So it's very easy to just play with them, with the data after. While originally it was using the protobuf classes that were difficult to actually call directly if you didn't know the specifications. Another cool thing that Matteo had the idea to put is the context manager, meaning that getting more Pythonic here, we can use the with statement and do whatever we just did all at once like this. So we open with the connection, we give an alias here, and then we deploy and propose like just we did before. And then we directly use the same output and stuff for the blocks. And after we get here, the connection is closed. So this is nice. And as you can see, it's actually pretty fast when you have a standalone version. So we have block 2 now, and this is the hash. And if we go to check here, this is what happened. Okay. Question up to now? I didn't show that much, but this is basically already how you would use everything except for interacting with the channels, which is the last thing that I'll show. So we can now take advantage of another method that was available for gRPC with rchain. It's listen for data at name. So we can wait for data that are produced by the block using this function and giving a channel name. So what we do is that we create like a channel name to be used in the code. And then I'll create here a Roland contract that will be something like this. So I'm just sending the message bar inside this channel. What it will happen in the code is that Python, our Python library will replace directly this placeholder with something like random name, like a normal channel. So if we do this with the with statement, it's just this function here, run and get value from.
Yeah, can you spend a little time on run and get value from? That was what I thought I saw earlier, because I saw it on your slide.
I'll explain how it looks like, and then I can get back and listen to questions. So this is how a random name for a channel looks like. We're using the secrets Python from Python library. So I can get this block that looks similar to the one that we get from get blocks, but there is something more now that is called post block data, which is the usual output that we would see from the channel. So since I gave that channel, I can use directly the Python code on the block to get the results, to, parse the post block data, which has messages, and the first message that I see is here, bar, which was printed from the channel. So let's go back just to make sure. Oh, I have to do this. Okay. So if you see here, I was sending this message here to a channel. What I did, it was replacing this channel here to get the block data with the listen on. And the result is that I directly get only in the code in Python the output. And I can just parse it like a normal variable. So this is the missing piece that was needed for us to interact with our voting contracts Just because like this, we can eventually create hashes directly on the chain and get the hashes back, or give a way for people to verify that the hashes that we gave as receipt when voting are actually what they get back from our chain when they query our tally channel. Let's say it will be like a read-only channel. I don't know if you guys want me to complete this part by showing something that I was able to put up today, the name registry usage. Because updating to 0.7, I can actually use the name registry capabilities. There is a link there to the specific usage of how it is. But what we could do now is just that we write a contract which has an unforgeable name instead of a public one, which is the one that I usually use. Now we can register this name to the name registry and get it the ID directly in Python for the lookup, which is something extremely helpful. And so what we could do, or programmatically from Python, and we can almost call a contract in a secure way. I said almost here because, of course, I have to double check everything. It's just something that I did today. I don't know, like all of the parts that could be have eventually a problem. Let's show the flow here, and then we can talk about it. So what we do is register a contract. It's very easy. It's this kind of code where we are using now this built-in method registry insert arbitrary, and we call it with a bundle for read-only with this new name that I'm registering here. And so I can create a contract with this unforgeable name now. And what I'll do is to use the trick that you saw for the listening on data to add here a placeholder. And so I'll send to this channel directly in the same code, the from registry message. The message should be the register ID that I need to use. Okay.
What's a bundle?
Bundle is a way to avoid that a channel can be either, to change a channel to be either only to be read mode and write mode for the people that will have access to it. So this, it's important to, as far as understood, to combine this with the register, because otherwise people could just go there in the same channel and provide something different as a name. And
is the concept of bundle or this particular object or keyword or method, whatever it is that an rchain specific thing?
Yeah, it was available already before the 0.7.
Ah, okay, thank you.
You're welcome. Okay, so we have the famous placeholder here. When I run this code, what happens is that I'll get the output, and as you can see already here, we also get from registry and the ID in the famous post block data. Now, one thing that we are, let's say that it's a work in progress, is to get correctly these things from these blocks, because as you can see, it's really like annoying how it goes deep into nesting when you get these things from the blocks. So as you can see, the data will look like this, and then there is a list of a dictionary that has a double list and stuff like that. So to get this correctly, you have to do something like that, which is not really Pythonic, and it could break in time. So another possibility might be to actually use JSON and dump that content like a string like this, and then do some regular expression. So if we do this, like get the row ID and whatever is not like a quote, we get correctly this string, which is the one that we need to use here. And so finally, what we could do now, since we have the ID directly in the code, is to look up and call the contract. So we will use the other built-in method, which is the registry lookup here, and use the for on this value on the lookup, and I'll get the contract here name that could be used. I'll call it with a message to see if it works. So this is how the code will look like. Let's call it and see. And here it is, so works. This contract was called from the registry name directly in Python. Very nice. So I hope to explore this thing more and understand all of the implications, because it's a complicated concept that it's very new into the blockchain thing, and it's really nice. So I'll be going over and over on this soon. I guess that's enough, just because I didn't want to take too much time, but just rather show that it's very easy to use the Python code that we have here to do the basic stuff that you will need. Any question?
Sorry, this is Goodness.
Yeah, hello.
I don't know. Yeah, is this session recorded? Because I joined in late, and I would love to go over later.
Yeah, as far as I know, yes.
Okay, it's recorded. All right.
Yeah.
I would love to have access to it at the end of the
Sure.
stuff. Okay, thank you. Thank you.
You're welcome.
Yeah.
Any other one experiencing already something with the name registry? More a question like for me instead. I guess not.
One question. I think you said something wasn't working because of protocol buffer issue.
Yeah,
what is that?
The point is that, okay, so I don't know if you have any experience with that. The gRPC is using protobuf to share the definition of the server methods to the client. And when you use those things, they have like parameters and stuff like that. Some of them are complex, meaning that they have embedded definitions of other classes inside the parameter. And one that you need to use for listen on requires some complex attribute. And I don't know why. Python has some issue in verifying which is the attribute that you are showing. So you're supposed to, import this class from the protobuf definition. And what I ended up with is that the parameter I had inside the class needed for the listen on wasn't recognized as the same class as the one used from the server, but actually it's the same one. It has the same name, but somehow with meta classing or stuff like that, that I don't know which is if that is either fault from rchain or protobuf. I guess more the protobuf thing actually. They have not the same ID, so that's probably why it's complaining. So what I had to do is to fork the protobuf and just change one line where it's checking this class, and then it started working after that. So meaning that the class is, the definition that I'm using is the right one, but somehow it's not recognized at the moment from Python. So they should help me, I guess, I hope, to find a way to overcome this issue. So until I don't fix that, I cannot release the updated gRPC version for 0.7, because you will need to have this workaround that I'm using, which is not really nice.
In the protobufs definitions, I forget if this is in row types or the Casper messages, there's custom collections. Is the way that you're processing the protobufs, and I guess this is the same question perhaps for Joshi on the rchain API, are those collections being processed or ignored?
No, I mean, I'm actually not processing anything. I'm just importing the definition that I get from automatically generated gRPC client. So what I do is that to generate the ones that I have for Python, I have to download the release that I'm pointing out in the rchain repository, and then use the Scala definition that they have to generate the Python files automatically, and then import the classes that are generated from there. So I wouldn't touch that code, absolutely. And you usually just create instances from there, that's all.
I think I understand. So you're using the same compile stream that that the rchain used?
Yeah.
Okay, and therefore you're getting those collection classes. Okay, thank you.
Is it correct that if you use the Docker images, you don't have to worry about having the correct version of everything? You just won't get the latest features, 0.7.
Yeah, if you're using the notebook that I'm sharing right now, the master version, it has the patch for the 0.7. So if you want to play with that, you could already. By not doing anything, you just use Docker and use that image there. Yeah, sure. Okay. For me, it's enough if there is no other questions. And I will really happy to also have other questions or some other discussion about this on Discord later or in the upcoming days. Okay?
Could you clarify a little bit about the eval and REPL support?
Yeah, it's if I run that, because of just like the connection for Casper, you just use the definition for REPL and eval just like that in the same way. And if I do that now, it throws an error just like a not implemented model. And it's either meaning that that is really missing or if there is a mistake for some reason. So from, I don't remember who was that, probably Ed, who said that, that there was, they don't want to share those. Maybe that's not actually a mistake, but it's voluntary. So I'll check it out and let you know.
I'm not sure actually there's a, port 40401 is the external gRPC, but there's another port that's an quote unquote internal gRPC, and I haven't attempted to get a response out of that one. It may be available on a different port.
Right. Yeah, I'll let you know. So if either you or me or somebody else knows first, let's share.
I think, this is Joshy. I don't know for sure, but I thought it was regular 40401, and Ed, there's a PR against rchain API that I haven't really looked at very much that does the REPL and eval there. So that might be.
Does it work for you?
I didn't write the PR and I haven't reviewed it yet, so I don't really know.
Yeah, but these people that presented probably have tested and it works, I guess, no?
Sorry, what was the question?
I mean, the people that presented the PR probably already tested the code and it works. Otherwise, they wouldn't. I don't know.
I don't want to speak on their behalf. It was a dude named Justin from Pyrofax. He didn't give me the impression that this was like super ready and gonna be merged or anything like that. Just that he's working.
Okay. Thank you. I'll follow the issue also.
Paulo, I'm so impressed, and this demo was awesome. I'm going to study every slide a little bit slower so I can grok it, but really impressed with you.
Not much Python code, so it will not take long. Don't worry. I'm happy that you liked it.
Really impressed.
Yeah, big thanks from me too, Paulo. I really appreciate you spending the time and the work you guys are doing on the Python code. Very nice.
Thank you, guys.
Yeah, it was awesome. Right. Can someone tell me where the links are? I guess I missed them. Maybe pop it in the chat.
They're on the developer Slack or Discord channel, right?
Yeah, I shared them in the developer channel, but you can also ping me directly on DM for information.
Less than an hour ago, they're on Discord development channel.
Okay, thank you so much.
Thank you, guys. See you soon.
Thank you.
Ciao, ciao.